binomials. Super exciting, right? Okay. I want to first start by talking about dividing by a monomial. That means a single term, right? So when you're dividing by a monomial, you're going to divide each and every term by that term. All right, so an example of this would be if I had 3x to the third plus 7x squared minus 2x plus 1. And I'm dividing it all by 3x squared. Because we have a single monomial in the denominator, we can put 3x squared underneath each term and simplify. So I would write 3x to the third divided by 3x squared plus 7x squared divided by 3x squared plus negative 2x divided by 3x squared plus 1 divided by 3x squared. And simplify each one. The very first term, my 3's cancel. X squared goes in the top twice, and I'm left with only x plus. The second one, the x squared simplifies, so I have 7 over 3. And then plus or minus, however you want to think about it. The 2/3 stays, and where do I have an x left over? In the denominator. And then plus 1 over 3x squared. Okay, so if we're dividing by a single monomial, we can do that. We can split it up. However, today is much more fun than that. That would be your answer, yes. Okay, today we're going to divide by binomials and trinomials. So, before we get into dividing by binomials and trinomials, I want to remind you what long division is all about. Okay? So, let's say I have, 2,643 divided by 4. Okay. Yes, we're going to do the house. Under the house is 2,643. Outside the house, as you said, is our 4. No, it's division. Correct. 4 goes into 26 6 times. Then we multiply 6 times 4 is 24. We draw a line and we subtract these. We get 2. Then we bring down the next number. 4 goes into 24. 6 times. 6 times 4 is 24. And then you got to bring down your 3. 4 goes into 3 0 times, and we're left with a remainder of 3. If you were putting a decimal point there, you would. But we're going to talk about remainders today in here. Okay? You have remainders in polynomials. It's super fun. Yes, you did. You absolutely did. All right. So, here we go. When we are dividing, you're going to put your big polynomial under the house, as you guys called it. And what we're dividing by, the binomial, is going to go outside. So, my first example, I'm going to start with, we have 6x squared plus 7x plus 2. And I would like to divide by, oops, that wasn't very straight. Let's divide by 2x plus 1. Okay? So, just like you did when you had a number up front, we're going to think about what's the front number of that binomial. So what I always say to myself when we're doing this, what times 2x is going to give me 6x squared? 3x. I agree. And I'm going to put that right above where my x term is. So I'm putting 3x right here. And just like we did along with the divisions before, we multiplied, right? So 3x times 2x is 6x squared. 3x times 1 is 3x. Now here's where the tricky part comes in. We drew our line and we subtracted. So you need to subtract all of them. So what I always say is draw your line, change your signs, because that represents subtracting. Okay, so we change our signs. 6x squared minus 6x squared, those cancel. 7x minus 3x is 4x. Then we bring down our next term, so plus 2. What times 2x gives me 4x? So plus 2 on the top, right? 2 times 2x is 4x. 2 times 1 is positive 2. Draw your line, change your signs, add them together, so we have no remainder. Your answer is 3x plus 2. Okay? Alright, so this is not bad at all, I promise you. It's just long division. This isn't even really, I didn't even put it under example. It's just kind of like the process of what we're going to do. Now, here's one of the things I want to talk about. Is if it divides evenly, like this one did, then both of those are factors of 6x squared plus 7x plus 2, right? So I'm going to put that right here in my notes. Since divided evenly, then both binomials are factors. All right, we're going to step this up a little bit. Here we go with example number 1. Example number 1. I'm going to start by telling you that we have 3x to the 4th minus 4x to the 3rd plus 7x squared minus 2x plus 1. And I want to divide this by x minus 1. Sounds good? All right, so the first one goes under the house, right? 3x to the 4th minus 4x to the 3rd plus 7x squared minus 2x plus 1 divided by x minus 1. So I start right at the beginning. What times x is going to give me 3x to the 4th? 3x to the 3rd, right? I put it right above my 3, so I keep everything lined up. 3x to the 3rd times x is 3x to the 4th. 3x to the 3rd times negative 1 is negative 3x to the 3rd. Those first terms should always drop out, okay? So we're going to draw our line, change our signs. Now we add them together, okay? Draw your line, change your signs. 3x to the 4th minus 3x to the 4th, they cancel. Negative 4x to the 3rd plus 3x to the 3rd is negative 1x to the 3rd. Now I bring down plus 7x squared. All right, what times x is going to give me negative x to the 3rd? Negative x squared, right? Negative x squared times x is negative x to the 3rd. Negative x squared times negative 1 is positive x squared. Draw my line. Change my signs. My negative x to the 3rd and positive x to the 3rd cancel. I have 7x squared minus x squared is 6x squared. Bring down my minus 2x. What times x gives me 6x squared? 6x. 6x times x is 6x squared. 6x times negative 1 is negative 6x. Draw my line. Change my signs. 6x squareds cancel out. Negative 2x plus 6x is 4x. Bring down plus 1. What times x gives you 4x? 4. Alright, so we have, move that up a little bit. 4 times x is 4x. 4 times negative 1 is negative 4. Draw your lines, change your signs. When we add these together, we get 5. So up at the top, let me move this out of the way. We're going to write remainder 5. Exactly. Okay? The only thing you got to watch for is when you draw your line, change your sign. Key thing right there. If you miss changing a sign, throws everything else off. Okay? No. All right, here's example number 2. Not that much work. You guys are fine. 3. Okay? All right, so technically it's numbers 9 through 16 are all the same. So we're going to start at. And I want to start by throwing a difficult one in just by saying, because there's something we got to talk about. If I have x to the third minus 13x minus 12, and I want to divide by x minus 4. Whoops, that's not an x. X minus 4. Sorry, guys. All right. So you'll notice in that polynomial that's up there, I'm missing a term. I go straight from x to the third to x. So when I write it down, I need to put what we call a placeholder. Okay? So I'm going to write it as x to the third plus 0x squared minus 13x minus 12. And I'm going to divide by x minus 4. All right, what times x gives me x to the third? Good. X squared times x is x to the third. X squared times negative 4 is negative 4x squared. Draw your line, change your signs. Your x to the thirds drop out. We get 4x squared. Bring down minus 13x. What times x gives me 4x squared? Good. 4x times x is 4x squared. 4x times negative 4 is negative 16x. Draw your line, change your signs. Your 4x squareds drop out. Negative 13x plus 16x is 3x. Bring down minus 12. What times x gives me 3x? Good. 3 times x is 3x. 3 times negative 4 is negative 12. Draw my line, change my signs. What's my remainder? 0. And since it came out as 0, that would mean that this is a factor. Okay? No. The only reason I'm telling you is because in example number 3, example 3, which covers the last two problems, 17 and 18, determine if, let's go with x plus 3 is a factor of x to the third plus 4x squared plus x plus 6. Oh, minus 6. Change it up. All right. So if I want to know if it's a factor, I want to divide it. And if it is, what's going to happen? Yes, you'll have no remainder, right? That's all we got to do. Here we go. Last one. X to the third plus 4x squared plus x minus 6. We're dividing by x plus 3. All right. What times x gives me x to the third? X squared times x is x to the third. You guys sound so excited. X times 3 is positive 3x squared. Draw my line. Change my signs. 4x squared minus 3x squared is just 1x squared. Bring down my plus x. What times x? will give me x squared. Good. X times x is x squared. X times 3 is 3x. Draw your line. Change your signs. X squareds drop out. I have x minus 3x is negative 2x. Bring down negative 6. What times x gives me negative 2x? Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Draw my lines, change my signs. I have a remainder of 0. So yes, it's a factor. Okay, so you have a couple of them, though, that are like example number 2, where you got to put a placeholder. Don't let that trick you, okay? All right, go for it.